Hey everyone, and welcome back to the podcast. Mark here, and as always, I'm joined by the ever-inquisitive Jenny.
Hey Mark! Always a pleasure to be here, ready to dive into another fascinating corner of the tech world. And today, we've got something really times cool. We're talking about how NASA, yes, times that asterisk NASA, reinvented the mechanical battery.
Oh, this is one of my favorite topics. I mean, when you think mechanical battery, you probably picture, like, a wind-up toy, right? But NASA took this concept to a whole other level with flywheels.
Okay, wait, flywheels? Like spinning wheels storing energy? How does that even work in space?
That's the genius of it. So basically, a flywheel is a rotating mass. Think of it like a spinning top. The faster it spins, the more kinetic energy it stores. NASA's innovation was to use these not just for energy storage, but also for spacecraft orientation.
Hold up, orientation. So it's like a two-in-one deal? It's storing power and times helping the spacecraft stay pointed in the right direction?
Exactly. They use gyroscopic principles. You know, like how a spinning top resists being tilted? That same principle helps keep the spacecraft stable. It's incredibly efficient. Because, in space, every ounce counts. Having one system do two jobs is a huge win.
That makes so much sense. Weight is everything in space travel. So how do they keep these flywheels spinning without losing energy to, like, friction?
This is where it gets really interesting. They use magnetic bearings. Basically, the flywheel is levitated by magnets, so there's almost no physical contact, which means almost no friction.
Magnetic levitation? Wow. So it's just floating there, spinning freely?
Pretty much. And to make it even more times efficient, they put the whole thing inside a vacuum chamber. No air means no air resistance slowing it down.
A vacuum chamber and magnetic levitation? That's some serious engineering. It sounds like something out of a sci-fi movie.
It totally is. And the results are amazing. We're talking about incredibly high energy efficiency. Like 98% in some of the terrestrial applications they've developed from this technology.
98%? That's wow. So how does this compare to, say, the lithium-ion batteries we use in everything these days?
That's a great question. Lithium-ion batteries have a higher energy density, meaning they can store more energy in a smaller space. But flywheels have some major advantages. They have a much longer lifespan. We're talking hundreds of thousands of charge cycles, compared to a few thousand for lithium-ion.
So they last a asterisk lot times longer. That's a big deal, especially for something in space where you can't just swap out a battery.
Right. And they're also much more resilient to temperature changes. Lithium-ion batteries can be pretty sensitive to extreme heat or cold, but flywheels can handle a much wider range.
That makes them perfect for the harsh environment of space. But you mentioned terrestrial applications. Are these flywheels being used on Earth too?
Absolutely. One of the most exciting applications is in grid stability. There's this facility, Beacon Power, that uses 200 flywheels to help regulate the frequency of the electrical grid.
200 flywheels? That sounds like a massive operation.
It is. They provide 20 megawatts of power, and they can respond to fluctuations in the grid incredibly quickly, much faster than traditional power plants.
So they're helping to keep the lights on, basically?
Exactly. And by doing that, they're also helping to integrate more renewable energy sources, like solar and wind, which can be intermittent.
That's fantastic. So what's the future of flywheel technology? Are we going to see them everywhere?
Well, there's still work to be done. One of the big challenges is increasing the energy density, but researchers are working on new materials, like advanced carbon fiber composites, that could potentially double the amount of energy flywheels can store.
So smaller, more powerful flywheels. That could open up a lot of possibilities.
It could. Imagine flywheels in electric vehicles, providing quick bursts of power for acceleration, or in homes, storing energy from solar panels. And of course, there's still a lot of potential for space applications, maybe even on lunar bases or future space stations.
It's amazing to think that this technology, developed for the extreme environment of space, could have such a big impact here on Earth. Thanks for breaking it down for us, Mark.
My pleasure, Jenny. It's always fun to explore these innovations, and it just goes to show you, sometimes the solutions to our biggest challenges can come from the most unexpected places, like a spinning wheel in a vacuum.
A perfect summary, and a great reminder that innovation can come from anywhere. That's all the time we have for today. Join us next time as we delve into another tech adventure.